Welcome back to Wildcat Academy. Today we're going to be talking about how to solve logarithm equations. So in example 1, we have a basic logarithm. Log base 4 of x is equal to 6. And in order to solve a logarithm equation, what you'll want to do is isolate the logarithm terms on one side by condensing down multiple logarithm terms or using your power properties to combine them. And so we already have that completed in this example. It started out that way. So we have a single logarithm, and then you just want to exponentiate both sides, and I'll write that out in this first example. So you can see that we use the same base. So we have base 4 in our logarithm. We want to make both sides the exponent of a base 4. And when we do that, on the left-hand side, the 4 log base 4 simplifies down just to the logarithm value of x. And on the right-hand side, 4 to the 6th power is 4,096. And we're finished. That's it. You can also think about rewriting this as an exponential form. And knowing how to do that takes a little bit more memory than remembering to exponentiate both sides. But you're just going to 4 to the 6th power is equal to the logarithm value x. And you end up with that same step there. But I think exponentiating both sides kind of fits with the way we solve other problems, taking the square root of both sides or squaring both sides or taking the logarithm of both sides. I think when we perform a function on both sides of an equation, I think it fits with the way we're trained to solve equations. In example 2, we have logarithm base 5 of x plus 3 is equal to 3. And we already have a single logarithm. The difference here is that we have a quantity, a logarithm quantity, x plus 3. So we'll have a subtract 3 step after we exponentiate both sides. So we'll take 5 and we'll log base 5 of x plus 3. And it's not really necessary to write this step out. You can go ahead and skip that step and just know that we're going to get x plus 3 is equal to 5 to the 3rd power, which is 125. And then we will subtract 3 on both sides. We'll get 122. And our problem solved. So, and we can always plug back in and make sure that that works. But log base 5 of 125, 5 to what power equals 125? That would be 3. All right. So in example 3, we have a quantity, logarithm quantity, and then we also have subtract 5. We have to isolate the logarithm in this case. So that's what we'll want to do. We want to add 5 to both sides, and we'll get log base 6 of 3x is equal to 2, and then we will exponentiate both sides and make that 6 log base 6 of 3x is equal to 6 squared. This gives us 3x is equal to 36. Divide by 3, and we'll get x is equal to 12. All right, in example 4, we have 2 logarithm terms. So we're going to have to use our property rules to combine these. And so the first thing we want to do is move the coefficient back onto our logarithm value. So log base 4 of x squared. And then we'll do that with the second term, log base 4 of x cubed is equal to 2. And then we want to combine these into a single logarithm. And since these logarithms are added, we'll use the product property, and we will multiply x squared times x cubed. And that ends up being x to the 5th power. Notice we haven't done anything to the right-hand side at all. We're just combining these logarithms so that we end up, just like we were working the first problem, with a single logarithm that we can now exponentiate both sides and end up with an equation that we can solve for x. So when we exponentiate both sides, making both sides base 4, like this, we'll end up with x we'll end up with x to the 5th power is equal to 16. And then we'll just take the 5th root of both sides. So when we do that, we'll end up with x is equal to the 5th root of 16. This ends up being 1.7411. And that ends up being our solution. So some very basic examples, introductory examples for how to solve logarithm equations. Remember that the key there is that we want a single logarithm value, whatever it is, so that we can then exponentiate both sides. And that is your goal. That's your first goal, is to really get an equation that looks like log base b of some x, however we get to that point, and then there should usually a number over here on the right hand side, something like a 4, and then we'll raise both sides to base b and we'll get x equals b to the 4th, where b is the base of the problem. If you found this video helpful, be sure to hit the like button and subscribe to the channel to catch the next video from Wildcat Academy, and leave a comment below if you have any questions about solving logarithms.